Today I'm going back to an old Mikey Smith recording from about a few months ago where he calls an observatory. I don't know if I'm going to show the observatory bit, but I might. But in the one part of the video, he goes through an image that is taken by an astronomer recording a session that he's out observing. And in Mikey Smith doesn't understand how compression works in computers. So we'll let Mikey talk for a bit, and I'll explain what this image is, and hopefully nobody complains that I'm using this image, and we'll talk about CGI and stuff after we let Mikey Smith talk for a few minutes.
Yes, big binoculars. What's going on here? We gotta go to history right there. Okay, perfect pausing. Perfect. All right, guys. We will take a look at the screen here. Just wait for my live stream to catch up on my phone. So pay attention to these dots. These dots in the sky. Of course, there are not that many stars in the sky. Holy doodle.
With the naked eye, we only see about 6,000 at most of stars in the sky, and there's actually over 100 billion, actually between 100 and 400 billion stars in the galaxy. So there's a lot more stars that are there than he thinks there are there.
Not sure. I've never seen this many stars in the sky ever. This is very, this is like a $5 program, if that's what he's using. Okay, so we will watch you may have to take screenshots, and you see we can almost, so right now, this star right there is on top of the power line, if those are actually power lines. So that one there, and we will just keep on moving and watching. So you can watch this star here. It will eventually go over the power line. Those stars right there are overpowering, overlapping, overlaying. We'll just go nice and slow for you guys. And you can see, look at this power line. It's littered with stars on top in front of the supposed sky behind these power lines. These are all stars on this power line right here.
What he is seeing is compression artifacts. When data is transmitted over the internet, it's often encrypted and often compressed, so it goes through the internet a lot faster. And also it goes in little packets, and sometimes the computers have problems putting together these packets and the compression. So you get these errors where it looks like the stars are overlying the lines. Okay, now I'm going to go into the CGI argument, because I don't feel like listening to him talk about this for any longer. A lot of flat earthers think the night sky is faked, and they use CGI to do it. But the thing is astronomers have been taking pictures of the sky for almost 200 years now. Ever since photography came about, the daguerreotype type was very early adapted for astronomy. Above you see, I'm going to show you a couple of plates from a Smithsonian article about how these old plates are still being used. One above is the sun during an eclipse in 1919. This was 4 years after Einstein predicted general relativity and how a gravitational body would shift the light coming from an object. And what is above is one of the plates from a guy named Sir Arthur Eddington, who went on an expedition, and I can't remember where, but they took the images of the sun in front, the moon in front of the sun, and to see if there was if the position of a star behind it was changed. They found that, but some people, there's evidence that these plates weren't that great. But there's been many other experiments of during lunar eclipses of people finding this out. Plus, there's also gravitational lensing from other objects like an Einstein cross. The next image is from Edwin Hubble, taken at the Mount Wilson Observatory. And this is an image taken of the Andromeda Galaxy. The letter N is, he thought, was a supernova, but it's actually a Cepheid variable, which is a variable star. They go between 1 and 1,000 days. There is a relationship that was found by Henrietta Swan Leavitt about the same time, and basically the longer the period of the pulsation, they change brightness over time. Sorry for all this. They change brightness over time. But the more massive the star, the longer the shift in luminosity or the brightness of the star. They shift between 1 and 1,000 days. I just looked this up yesterday for something else. What Hubble did was he found supernova and correlated the distance and correlated the two, and found out that, and the redshift of stars in the galaxy, and found out the universe was expanding. The other one is Annie Cannon, who was the curator of these glass plates at Harvard. And in Harvard alone, there's 300,000 of these things. And what she's doing is looking through it and looking for objects in the plates. I actually handled similar glass plates. They weren't as big as these ones. They were smaller. They were for a cluster called P Cygni. And what I did was measure the relative brightness of the stars in them in through different filters, like blue, visible, and red, and red. And you can figure out how much dust is in between the stars and the distances between where the stars are in the cluster. So they're still they were still being used 25 years ago. Now they're being scanned. Since then they've been scanned into computers, so they can use computers to do the comparisons instead of using machinery. But these glass plates exist, and it was before CGI. Okay, I'm not going to show the observatory ones because it's kind of making fun of him calling a raptor observatory, and the raptors are birds, not stars. So I hope everybody has a good day, and goodbye, and have a good one.